Hi, this is section 3.6, which is about derivative of logarithmic functions. So the objective is to find derivative of a logarithmic function and use this method to find derivative of functions. So before I start the lecture, there are some tools that I will recall here. The first one is the derivative of ln u of x. So when you have a function inside the ln, then the derivative of this function will be u prime over u. We'll use this many times in this section. And also you have to recall the property of logarithmic functions. So ln a times b is equal to ln a plus ln b. And ln a over b, this is equal to ln a minus ln b. And the last one, ln a power n, which is equal to n ln of a. Okay, so these tools will be helpful for the examples later. So the idea of derivative of logarithmic function is the fact that sometimes the expression of the function is a little complicated. But imagine we have y equal to f of x, the function, and this expression here is very complicated. So the idea is to apply the ln here and here, and use the property of ln to simplify what you obtain here. That's why we call this logarithmic function. And then you will differentiate the identity, the new identity. So first step, you have y equal to f of x. Second step, apply the ln. Third step, use property, expand. And fourth, d over dx, make the derivative. Then you will obtain something which is easy to compute. Then you can find y prime. We will see this in the examples. Okay. So we know that the derivative of log b of x is 1 over x ln b. This is this coefficient comes when we use base b for the logarithm. So if the b is equal to e, log e is ln, and we find the famous result, ln x derivative is 1 over x without any other coefficient. Okay, so this correction is coming from the fact that we take base b. Okay. Look at this example, and here we use the ln, the usual log with base e, to find the derivative of this function. So y prime is equal to, this is of the form ln u of x, so it will be u prime over u, and u prime is equal to 3x squared over u, which is x cubed plus 1. This is the u, okay? And that's it. So this is kind of chain rule. Here another example. Also, you will find that it's called this f prime of x equal to derivative of ln sine x. So the u is the sine, okay? So over sine x, and derivative of sine is cosine. So somehow it's cotan x. Example 3 here, there is composition of functions. So I will choose g of x equal to root x and h of x equal to ln x in the way that f will be j composed with h. So the derivative of this will be j prime equal to 1 over 2 root x, and h prime will be 1 over x. Okay, so the f prime from the composition, the chain rule is 1 over 2 square root of ln x times 1 over x. And that's the derivative. Okay, now we have the try and check example for 1. So it's a derivative of this ln function. So first it is x plus 1 over root x minus 2. That's the u, function u here. This is u. So u prime over u. And here u prime is a little bit complicated, so I will work on it separately. So the form of derivative is this one, f prime is equal to this one, but it needs some auxiliary computation. So x plus 1 over root x minus 2 square prime is equal to root x minus 2 squared, that means x minus 2. And in the numerator, derivative of x plus 1, that's 1 times the root, and minus x plus 1 times the derivative of root, which is 1 over root x minus 2. And you see here that there is denominator in the second term, so I will make the same denominator, and it will give x minus 2 over root x minus 2 and minus x plus 1 over root x minus 2. That will give, in fact, I will put the denominator in the principal denominator, so root x minus 2 here. And I will have x minus 2 minus x minus 1, because there is minus here, so minus in front of everything. And the x will cancel, and I will have minus 3 over x minus 2 times root x minus 2. Plug this in the result here, and the derivative will be equal to minus 3 over x minus 2 root x minus 2, and flip the denominator, this one will be flipped, so times root x minus 2 over x plus 1. So simplify by root, and then we will have minus 3 over x plus 1 times x minus 2. So that's the derivative of this function. Now the second one, number 2. Since here we have absolute value, we recall the definition of absolute value. It is equal to x if x is greater or equal to 0. But since here I have ln, I cannot put 0, so it's positive. And minus x if x negative, I cannot put 0 also in the second one. That's the definition of ln absolute value of x. Now ln of x will be, of course, piecewise defined function ln x if x is positive, and ln minus x if x is negative. And of course, the second one is well defined since x negative and minus x will be positive inside the ln. Now we can differentiate. So ln absolute value of x prime will be equal to, we know that ln of x derivative is 1 over x if x is positive. And ln minus x is equal to, by the chain rule or the rule of ln u, so it is equal to minus x, and the derivative of minus x, this is minus 1. So if x is negative, so you see here that we can get rid of this minus. And in fact, in final, we will have all the time 1 over x. So the conclusion is that ln x prime will be all the time 1 over x. Of course, if x is not equal to 0, we can gather the two cases here together. Okay, we cannot take x equal to 0 in this expression. Good. Now we start with the logarithmic differentiation, and here are the steps. So the first step is to write the equation y equal to f of x, take the logarithm, use the logarithm laws, and then make the derivative with respect to x, solve the resulting equation for u, y prime is the unknown. And finally, you will replace y by f of x to get the expression in terms of x only. Look at this example. This is very complicated when we think to make the derivative of this function. However, if we take the logarithm, ln y, it will be easy because we know the rules of ln. So it's ln x power 3 over 4 plus ln root x squared plus 1. And this is in the numerator, since it is product, so it's plus. And the denominator become with minus. So minus ln 3 x plus 2 power 5. And you know that the power in the ln will be in front of the ln. So this is 3 over 4 ln x. This is also 1 over 2 ln x squared plus 1. By the way, we cannot get rid of this power since it is not on the whole thing. So we let it like that. And finally, minus 5 ln 3x plus 2. Now we will make the derivative. This is ln y. So do d over dx of this equation here. Ln of y prime, this is y prime over y. Remember the formula of ln u of x prime. Okay, equal to 3 over 4, that's constant multiplied by a function. Derivative of ln x is 1 over x. And then 1 over 2 multiplied by ln u prime. This is u prime over u, so it's over x squared plus 1. And the derivative of x squared plus 1, this is 2x. And finally, minus 5 over 3x plus 2. All the time is derivative of ln u of x. And here 3. Okay, so finally we will get 3 over 4x plus x over x squared plus 1 minus 15 over 3x plus 2. If we want to get y prime, then y prime is equal to all these multiplied by y. But y is this quantity. So just write it, x 3 over 4 root x squared plus 1 over 3x plus 2 power 5. That's the expression of y prime. Good. Another example for the try and check example here. So 1, we apply the ln here. Ln y is equal to ln x power root x. So this is equal to root x ln x. And now we can differentiate d over dx of this equation will give y prime over y equal to, and this is product. So it's 1 over 2 root x ln x plus root x times 1 over x. And you will conclude that y prime is equal to y multiplied by what I have here. So it's ln x over 2 root x plus, and this can be simplified, 1 over root x. Okay, and finally you will replace the y, so y prime is equal to x root x multiplied by ln x over 2 root x. Or let's do it common denominator, so it's plus 2 here. Okay, so that's y prime. Good. The second example here, you see that the expression is widely complicated, but with ln it will be simple. So there is half power all the functions, so it's 1 over 2 ln of x minus 1 over x squared x fourth plus 1, which can be written like 1 over 2 ln x minus 1 and minus half ln x fourth plus 1. Now make the derivative e over dx of this equation will give all the time ln y, this is y prime over y, and it is equal to 1 over 2 1 over x minus 1, because the derivative of x minus 1 is equal to 1. And then minus, I will continue here, minus 1 over 2 over x4 plus 1. That's the function inside the ln, and its derivative is for x cubed. So somehow we will simplify by 2, and this becomes 2. So finally, y prime is equal to the quantity to the right multiplied by y, but y is this function, root x minus 1 over x fourth plus 1 multiplied by 1 over 2 x minus 1. Sorry for this interruption. So here it is, 1 over 2 x minus 1 and minus 2x cubed over x fourth plus 1. Okay, so that's the y prime. Okay, now the next example here, an application of logarithmic differentiation. So if we have f of x is equal to ln x, then f prime is equal to 1 over x. That is, f prime of 1 in particular is equal to 1. So here we will make the link with the e number. E is the number equal to 2.71 and something. So we will see that we have an exact definition of this number e using the derivative. Okay, so if we write the definition of the derivative of any function f at the point 1, it's like this one. And then we will apply for f equal to ln x. Okay, so it will be ln 1 plus h minus ln 1, but ln 1 is equal to 0. So it will be like ln 1 plus h over h when h approaches 0. In other words, we can write this. Look at this. So ln 1 plus h over h. This is in fact equal to 1 over h times ln 1 plus h. So this coefficient here can go to the exponent of the function inside the ln. So this is in fact equal to ln 1 plus h power 1 over h. Okay, that's why we wrote this condition. We can change the variable, of course. Doesn't matter h or x. So we can write this like that. And in fact, this is equal to f prime when f is the ln, but f prime of 1 is equal to 1. So this limit is equal to 1, in fact. Okay, so this allows a conclusion for the E number. So when we take exponential of this, of the last equality, sorry, when we take E here and E here, we will get E power 1, which is E, the number E, equal to E of the limit, and E of the limit is limit of E. And when we have here E and ln, they will cancel each other. So we will keep just 1 plus x power 1 over x, and that's the limit that we have. E is the number satisfying equal to the limit of this expression when x approaches 0, that we can write differently also. We can write it like that also, like this way, or also we can write it like in terms of if we put n is equal to 1 over x, this power we call it n, so the power becomes n, and the x become 1 over n here. So it's a limit when n approaches infinity, because the x approaching 0 gives that n approaches infinity. So that's why it's another writing of the number E. Okay, by that we finished 3.6. Thank you so much.